Hi, everyone, and welcome to a new section on geometry. This time we'll be talking about perimeters and areas. After talking about points and line segments and rays and lines and angles, now it's time to talk about how to calculate a perimeter and an area of a two-dimensional geometrical object. Like I said in the previous lecture, you should be familiar with these things. So after you finish this section, you should be able to understand or use the formulas for perimeters and areas of polygons. And you can use those formulas to solve real world problems involving one, the Pythagorean theorem, and the other one involving any theorem or any formula around parameters and polygons. And there's a term, so when the shape or when the geometrical object happens to be a disk or a circle, we don't use the word perimeter, we use the word circumference. So you will see how are we going to use that again to solve some problems, some geometrical problems. Okay, well, let's get to start. So the parameter P of a two-dimensional figure is the sum of the length of the sides of the figure. And what is the area is the measure of the region that is trapped within the boundaries of that figure. Those are basic definitions. So if you have a rectangle, right? So if you have a rectangle, so let's see here, I'm going to draw a small rectangle here. Has length L and width W. So what's the parameter? Is twice the length, because this plus this plus this plus this, the parameter is twice the length plus twice the width. And what's the area? Is the length times the width. If a square is a rectangle, right? You just, the only difference between a square and a rectangle is that a square, all the sides are equal to each other. So the width and the length are the same. So we call it S side S. So what's the parameter? Is 4 times S. And what's the area of a square? Is S times S, which is S squared. If you have a parallelogram, right? If you have a parallelogram, what's the parameter? Well, it's twice this plus twice this. So this is B and this is W. So it's 2 times B plus 2 times W. And what's the area? Well, if you take a parallelogram, right, and you draw here a line that forms 9 degrees, and we call this H, and this is called B. So that's B times H. B times H is the area of the parallelogram. Now, if you have a triangle, any triangle, it doesn't have to be of any particular shape. So you have, let's say, S1, S2, S3. So those are the sides of the triangle. Well, the parameter is just the summation. It's just the sum of all the sides. And what's the area? If you have here H and this is B, right? So if you have from one of the vertices of the triangle, you make a 90 degrees, you project that on the opposite side of the triangle from a 90 degrees. So what's the area? Is half times the base. So this is going to be the base, and this is the height, or the height that goes with it, the H that goes with it. So half B times H. If you have a trapezoid, so a trapezoid it's an equilateral, and so it's a quadrilateral, it's a 4-side polygon where 2 sides are parallel. A rectangle is a trapezoid, a square is a trapezoid, a parallelogram a trapezoid, but a trapezoid can have can be none of these 3 shapes I just talked about. So how can you tell if you have a trapezoid or not? As long as you have 2 lines that are parallel, that's what makes the shape called trapezoid. So what is the parameter of trapezoid? Just add all these sides together. So it's S1 plus S2 plus B1 plus B2. If I call this B1 here and B2, B1 and B2, and if I call this H here, this is the height, from 9 degrees, the area would be 1/2 times H times the quantity, or times the sum of the bases, B1 plus B2, if you want to call them bases. Now, let me show you a picture. That's exactly what we're talking about. It's just this one here has a picture to to illustrate what we just did. So I would like you to pause here and then review what we just said, but this time using pictures. So this is a triangle and a square, rectangle, and a parallelogram, and a trapezoid. That's pretty straightforward. Well, here is an exercise. Rob wishes to replace the grass or sod on a lacrosse field. One pallet of Bethel Farms sod, so it's type of sod, we don't care what it's called really, costs $360 and covers 480 square feet. So one pallet, that's the price of it. And this is how much or how was the area that covers. If the area to be covered is a rectangle with length 360 feet and width 228 feet. So here, so what's the question here? So we'd like to know how much it will cost, right? And how much it will cost to cover this rectangular field. And how, also how many pallets. Well, like you see here, the solution. So what is the area of this field is 360 feet times 228, which is 82,080 square foot, right? So that's the area of the field that we would like to sod. And now how much is going to cost? Well, we're going to divide this area covered by one pallet, right? Because the exercise gave us that 480 square foot is covered by one pallet. So if you take the total footage or square footage, you divide by 480, that gets you 171. So Rob will need 171 pallets of sod. What was the cost? Well, we know the price of each sod. So you take 171 times $360. So it gets you $61,560 to cover this rectangular field with that type of sod. Very straightforward, really. I mean, that exercise could be on tiles, for example. You want to tile a rectangular room, let's say, and they will give you how much it costs per box of tiles and what is the square footage covered by one box. And you'll be able, when you go to a hardware store, you'll be able to determine how many boxes of tile you need and how much it's going to cost you to tile your room. It's going to be pretty much the same process. Okay, well, something that, again, that you are familiar with, they call the Pythagorean theorem or Pythagoras theorem. Pythagoras is Greek philosopher, mathematician, who did this, or who come out with this idea that he's now taught in almost as even early in the maybe lower middle school or even lower than that. It basically tells you if you have a rectangular or if you have a right triangle. What's a right triangle? It's a triangle that has one of its angles is 90 degrees, and that's why we use this symbol here to say this is a right angle. This is 90 degrees. So if you have a right triangle, the sum of the squares of two sides is equal to the square of the hypotenuse. So you have a squared plus b squared equals c squared. And this is now by Pythagoras theorem. Well, here's an application of Pythagoras theorem. We are going to assume that you have a ladder. Okay, and of course, this is a 90 degrees because we got to trust that the building is forming 90 degrees with the ground. So this is 18 feet. So this is 18 feet. This distance here is 18 feet. This one is 24 feet, right? And of course, how long must the ladder be? So we can call this x if you want. We can call it anything. So we know that this one squared plus this one squared is equal to x squared. Once you set up the equation, then you'll be able to solve for x. So here, well, they call it c. So this is c, and this is a here. And this is b. So we know that c squared is equal to a squared plus b squared. So a is 18, that's given by the exercise, and b is 24, again given by the exercise. 18 squared plus 24 squared. If you calculate this, it's going to be 900. So c squared is 900. So what is c? So how can you remove the square? You square root both sides. The square root of 900. Well, c should be either plus or minus 30, but since we're talking about a distance can never be negative by definition. So c is 30 feet. So the ladder needs to be at least 30 feet. Why? To have this configuration, right? So that's what, based on this configuration, the ladder should be 30 feet. Okay, now let's move to circles. What's a circle? Is a set of points that are equidistant from a fixed point that we call the center of the circle. So this is known by the center of the circle. It's a point, right? Now this distance is called radius. Double the radius called the diameter of the circle. Okay, well, the radius is the same. So this is r, and this is r, and this is r. So by the definition of the circle, any point you pick from the circle, it is making r feet, r meters, r kilometers, whatever units you are using between that point and the center. And twice the radius is the diameter. So this is a diameter. It's just a line segment, right? It has to be straight. You cannot say this is a diameter. So a diameter by definition has to be a straight. It's a line segment, right? Line segment that starts somewhere on the circle and somewhere else on the circle, but it has to go through the center. Now, what is the circumference or the perimeter? In other languages, they use perimeters. I did this in French, so they still call the perimeter of the circle. Here in English, we call it circumference of the circle. We don't use the word perimeter. So the perimeter is 2 times pi times r, and pi is a fixed number. It's 3.14 and on. So you use your calculator, you should have a button dedicated for pi. Or the same thing is the same thing as pi times d, because 2 times r is d, twice the radius is the diameter. So that's the circumference, that's the perimeter if you want to. And what's the area is pi times r squared. So if you know the radius of a circle, you already know how to compute the circumference and the area of that circle. Well, here's an exercise. Well, determine the shaded area or the blue area. Well, how can we determine the blue area? Okay, well, here they gave you, this is it looks like a parallelogram or something, right? It looks like a parallelogram. So this is 10 feet. And here, this is 2 feet, means that this is also 2 feet and this is also 2 feet. So the whole thing is 4 feet, right? Right, well, how are you going to determine the area of the blue region? Well, get the area of the whole paragram, right? Get the area of the whole paragram, everything. And then from that, you subtract the area of the circle. And that's how you determine the area of the blue region. Well, we learned that the area of the paragram is the base times the height. The base is 10, right? This is the base is 10. If this is confusing you, well, go back to one of, I think first or second slide, where we talked about the area of a paragraph times the height. The height is this one here, right? Which is 4, because this is a radius, but this is also a radius. This is also a radius, we get 4. So 40 is the area of the whole paragraph. But from that, we need to subtract the area of the circle, which is pi times r squared. So pi times 2 squared. So pi times 2 squared is 4 pi. And if you use the calculator, if you put 4 times and you hit the button of the pi, which is almost 3.14, you will see that this is 12.57. So the answer should be 40 minus 12.57, which is approximately 27.43 square feet. So that's the area of the blue region, of the shaded region. So like this exercise requires that we need to know the area of a paragram and the area of the circle. Well, as you can see, this is pretty much it. So every exercise they will give you in the homework or the test, as far as this goes, should be a combination of areas of one of the shapes we did, either rectangle, triangle, parallelogram, trapezoid, circle, and so forth. Well, you can go now and start your homework. And if you have any questions, please let me know.